the outer reaches of the solar system, orbiting Saturn, lies a celestial body that is physically and chemically distinct from all other moons in the planetary system: Titan. The fundamental feature that makes this moon, which has a larger diameter than the planet Mercury, unique, is its thick and active atmosphere. Titan is the only moon in the solar system known to have a significant and dense atmosphere. Composed of 95% nitrogen and 5% methane, this atmospheric layer is considered a surviving model of Earth's early chemical composition. In the upper atmosphere, ultraviolet radiation from the sun and energetic particles accelerated by Saturn's magnetic field constantly break down methane and nitrogen molecules. As a result of this photolysis process, complex organic molecules called tholins are synthesized. Tholins form the opaque orange haze layer enveloping the moon, and over time, they settle on the surface as microscopic particles, coating the moon's geological formations with an organic carbon layer. Beneath this thick atmospheric layer, Titan's surface temperature drops to approximately -179 degrees Celsius. At this temperature, it is physically impossible for liquid water, in the sense that we know it, to exist on the surface. Due to the extremely low temperature, water ice turns into a structure so hard and durable that it can be compared to solid silicate rocks on Earth. The mountains, plains, and crustal structure on Titan's surface are largely composed of this frozen water ice. However, this hard and frozen surface does not mean that Titan is geologically inactive. This is because Titan is the only confirmed celestial body other than Earth to have an active liquid cycle on its surface. But the cycle operating here is completely different from the water cycle on Earth. In this cycle, water has been replaced by hydrocarbons, such as liquid methane and ethane. Methane clouds, accumulating in the dense atmosphere, fall to the surface as hydrocarbon rains. These drops, which drift down through the atmosphere relatively slowly due to Titan's low gravity, physically erode the solid water ice rocks over time. As a result of this alien erosion, wide riverbeds, deep canyons, and vast river deltas are formed. These hydrocarbon rivers flow across the surface into massive basins, especially near the moon's north pole, forming churning seas of liquid methane and ethane. Kraken Mare, the largest of these formations, covers an area larger than Earth's Caspian Sea, with a surface area exceeding 400,000 square kilometers. Radar reflection data indicates that the depth in some parts of this dark alien sea exceeds 300 meters. The other parts of the surface, meanwhile, are covered with large elevations bearing the traces of active tectonic activity. The Mithrim Montes mountain range near the equator is one of the most prominent topographic features on the moon. The highest peak in this region reaches an elevation of 3,337 meters from the surface. This figure shows a striking similarity to the average height of the Alps on Earth. However, these mountains on Titan are not made of solid rock masses. They are made of hard water ice, pushed upward by the moon's internal cooling processes and crustal contraction, and thickly covered with organic tholin particles. The architect of this active hydrological system and these massive geological structures is Titan's gravitational interaction with Saturn. Titan follows an elliptical orbit around the giant planet. Due to this orbital mechanics, the moon's distance to Saturn changes periodically. The gravitational force Titan is subjected to increases as it approaches Saturn and decreases as it moves further away. This constantly repeating change creates a periodic stretching and relaxing motion on Titan's physical mass. This phenomenon, known in the literature as tidal flexing, affects the entire internal structure of the moon. Gravity and radar measurements taken from spacecraft have proven a staggering fact. Titan's surface stretches, rising and falling by up to 10 meters during its orbital cycle. According to the laws of physics, it is impossible for a celestial body composed entirely of solid ice and rock to flex by this much. The flexing margin of a solid mass is a maximum of just 1 meter. This massive 10-meter deformation indicates that the outer, hard ice crust can move independently of the Moon's inner core. This measurement is definitive proof of the existence of a fluid, liquid layer beneath the surface ice crust enveloping the entire Moon. Titan harbors a massive subterranean water ocean deep within its outer crust. The liquid water ocean begins approximately 50 to 80 kilometers below the Moon's surface. The reason liquid water at this depth does not freeze at sub-zero temperatures is the high pressure and ammonia compounds dissolved in the ocean water, acting as a kind of chemical antifreeze. However, as one descends toward Titan's center, the hydrostatic pressure exerted by the hundreds of kilometers thick ocean and the overlying ice crust reaches extraordinary levels. Under this extreme pressure, the thermodynamic balance of water molecules changes, and they simply cannot maintain their standard crystal structures. The water molecules are compressed, transitioning into exotic and high-density crystal phases known as Ice 6 and Ice 7, which are not found naturally on Earth. While normal water ice on Earth floats because its density is lower than that of liquid water, these exotic ice forms are heavier than liquid water due to their extreme densities. Consequently, these heavy ice crystals sink, descending toward the deep ocean floor. These sinking masses build a massive, thick, and solid ice mantle layer that tightly surrounds the silicate rock core at the center of the Moon. According to the gravity data obtained, Titan's internal structure, from the outside in, consists of 4 main layers: a hard water ice crust, a global liquid water and ammonia ocean, a high-pressure heavy ice mantle, and at the very center, a silicate rock core, partially heated by radioactive decay. The tidal flexing created by Saturn's gravity keeps all these internal layers physically active. The frictional energy and pressure fluctuations generated by this flexing occasionally cause deep fault fractures in the outermost hard ice crust. When these cracks form, the mixture of liquid water and ammonia from the pressurized ocean below erupts to the surface. This geological event, called cryovolcanism or ice volcanism, freezes instantly upon reaching the surface, adding fresh material to Titan's topography. The physical contact in these cryovolcanic areas between the complex organic molecules constantly raining down from the atmosphere and the liquid water coming from the depths of the ocean makes the Moon's surface a unique laboratory for prebiotic chemistry and origins of life research. This complex mass, which possesses a hydrological cycle like Earth's, but where water and rock behave in entirely different forms, continues to be one of the greatest focal points of planetary science